When the first mission to Mars is launched, people will live in space for extended lengths of time. They will need to produce food, water, and oxygen to survive. NASA scientists are experimenting on plants to develop onboard greenhouses that do just that. In one experiment, volunteer Nigel Packham spent 2 weeks in a pair of airtight containers. Instead of oxygen canisters, wheat plants provided all the air he needed to breathe. Plants absorbed the carbon dioxide Nigel breathed out and used it to produce the oxygen they both needed to survive. This exchange worked even when he exercised. As Nigel used up more oxygen and produced more carbon dioxide, the plants absorbed more carbon dioxide and produced more oxygen.
The plants have performed wonderfully. They react very quickly to me being here and to changes in my metabolic output. For example, if I sit on the bicycle and start exercising for 30 minutes, and I tend to put out a lot more carbon dioxide, the plants react very, very rapidly to that. So it's almost as if they know I'm here.
After 2 weeks, the experiment ended and Nigel emerged in good health. The results show that people can depend on plants for oxygen in an artificial environment. Now scientists want to know how long that balance can last.
Hi, Greg.
In another experiment, a NASA team manipulates the growing conditions of vegetable-yielding plants. Using artificial nutrients in high-intensity lamps, David Bubenheim grows plants 10 to 20 times more densely than they occur in nature. This is helpful for producing food in very limited spaces. Based on this prototype, they determined the size of a greenhouse needed to support a crew headed for Mars.
This chamber is about 200 square feet, and for a crew of 4 people, it would be able to supply and recycle all of the air and water, but it wouldn't supply 100% of the food in that case. To do that, you would need an area about 4 times this large, or a chamber about this size per person.
Since areas that large aren't practical in space, Bubenheim hopes that changing the color of light can solve the problem. Plants used in these experiments gather the energy they need from fluorescent light rather than sunlight. Changing the color of this light will change the way the plants grow.
If you look at these wheat plants that are growing under white light, like plants would outside, where all colors of the spectrum are represented, you can see that there are a number of smaller side shoots that are grown.
Side shoots are waste that has to be recycled. But growing wheat under blue lights eliminates these shoots, leaving the important center shoot unharmed. Red light works in much the same way. Scientists now want to know if the color of light has the same effect on plants other than wheat. If so, they'll be one step closer to an efficient plant-based system that can support life in space.